Hello. So today we are going to solve Codechef September lunchtime question number 1 watermelon. So in this question we are given a array of size n, an array of integers, and in each so let me name the elements of the array as a1 a2 up to an. So in this question we can perform an operation as many time as we want, and the operation was we can take ai element and decrease it with I. Okay, so like we can take the third element and decrease it with 3. So the goal of the question was we are given an array a, and what we have to and we had to determine whether we can make this array as a nice array, and the condition for being nice array was if we could make sum of array 0, then that array is called as a nice array. Okay, so this question was pretty simple because okay, so suppose I have some array. Let me take some random array 4 3 minus 1 minus 7. Okay, so let me take another array with this 2 4 3 1 comma 7 minus 7. Okay, so we have to make the sum of array 0. Okay, so this is our task, and we will see that there like we have one observation that whatever number of operation we do, we cannot increase the sum of array. We can only decrease the sum of array. We can never increase the sum of array. Okay, we can only decrease or let it be constant. So the answer, we just have to determine whether we can make this array a nice array or not. So the question is, though put in a like confusing manner, all you had to do was check the sum. Like all you had to do was check the sum of the element. If the sum is greater than or equal to 0, you will print yes, because if the sum is greater than 0, you can do the operation as many times as you want. So you can just decrease 1 from the first element and get it to 0. Or if the sum is equal to 0, we can just skip. We don't need to do anything. We can just say that the array is nice array. But if sum is less than 0, we know that we cannot increase the sum of the array. So it is but so if the initial array has its sum equal less than 0, so then we cannot so initial array okay wait initial array's sum, if that is less than 0, we can never increase the sum to 0. So it's very much evident that this array will be we cannot make this array a nice array. Okay, so okay, it was not a nice array, it was a good sequence, but anyway you got the point. So the thing is so for example, take this array. uh, so what is the sum of this array? 4 plus 3 7, 7 minus 1 is 6, 6 minus 7 is minus 1. So this the sum is minus 1. Therefore we cannot increase the sum minus 1 to 0. So this is not a good array, not a good sequence. But we can do this with this array. All we have to do is subtract 1 from the first element, and the sum of the array will be 0. Okay, so this is the question, and I don't think I should even write the pseudocode for this question, because all you have to do is like you have to just check sum of a, if it is greater than equal to 0, print yes, else no. That was the question. This was the first question. So we have solved the first question. Now let's look into the second question, that is GCD operations. So in this question we are given a number n and an array b of size n. Okay, oh yeah. So what we have to do in this question, suppose we have an array A such that all its ith element its ith element is equal to I, so the array A is 1 comma 3 up to n. Now our objective of this question is to convert okay, so in this question we have to check whether we can convert A to the array B which will be given to us, and we have to do the following operations. We can do a particular operation as many time as you want. So the operation is, we have to select so we'll start with the array A. Suppose my array is 1, okay, and I can choose any two numbers. Suppose I choose 2 and 4 and replace both of them by the GCD of those numbers. So GCD of 2 and 4 is 2, so I can replace this arrays by 1 2 3 comma 2. Okay, so our task is to determine whether we can convert A to B by using the following operations or not. Okay, so to talk about the constraints of the constraint of the question, we aren't receiving any test cases. So the all you have to do is our n, that is the number of elements in the array, are restricted to 10 to power 4. Actually this is a very loose bound, because the solution for this question uh, is of like the solution of the question is in big O of n times. So uh, we know this. Okay, so I will talk about the solution of the question. So the solution of the question is simple. uh, okay, so suppose we have two number A and B, and we find the GCD of A and B, and it comes out to be C. We know one thing about C, that is A mod C, that is remainder of A when divided by C will be 0, and B divided by C will be 0. Okay, so suppose now let's look at this array. Suppose this is our A array of when n equal to 4, and we have to convert it into this B. But I will write it properly over here. So our A array is something like this, and B array is like this. This is actually the test. I think example test case which they gave. Yeah, this was one of the example test case they gave. Okay, so yeah, so all we have to do is convert this array into this array, and it can be done in one step. All you have to do is select this 2, select this 4 in the first operation, their GCD is 2, and replace both of them by 2. So one thing we know about this GCD is the GCD will divide this number and we'll get remainder as 0. So what do we learn from this? That we get a condition to check. All we have to do is run the loop over the size of the array and check whether this number from array A gets is divisible by this number in array B. Okay, and if the mod is equal to 0 for all the numbers, we can say that say that this array can be converted into this array, else it cannot be converted. Now you might be wondering that you might be wondering that checking the remainder equal to 0 may be a necessary condition, but may not be a sufficient condition. But I have a proof for that only checking this remainder equal to 0 will suffice our condition of the will suffice our condition uh, for the string A to be able to be converted into a string B. Okay, so let me show you with an example. Suppose we have a large array like of some size n, and we have to convert it into this be the okay, hope you can see it. Suppose we have an array A of n size and array B also of n size, but we have to there are some numbers over here in which we have to convert the upper element. So how will I convert the array A into B? So I will if I have to convert n into some other number, so let's start with the last element of the array, that is the largest element. So if n is the largest element, then i- and also our element contains all the elements up to n, then this remaining array will have all divisors of n, right? So suppose if I want to convert n into something which is a divisor of n, what I will do, I will select n, I will select that divisor, and you know that GCD of a number and its divisor is actually the divisor itself. So I can select the number, select the divisor, perform the operation, the divisor will remain as it is, our number will be changed. So the number n will change to its divisor, which is necessary. So you might have figured out the thing that once I complete the operation with n, I have no concerns with n. I will do the same operation with n minus 1 and do so until I traverse the entire array. But we are not concerned, but actually this isn't asked in the question, how are you going to how are you going to perform the operation. I'm just telling this because this is a proof to why my method, like the remainder method will work. Okay, so suppose at any stage we find that the a, a's ith element is when divided by b's ith element doesn't equal to 0. So this implies that a is being converted, you want a to convert into something which is not a divisor of a, and that is not possible because a can only be replaced by a divisor of a, because GCD of a number is always a divisor of the number. Okay, so I think this proof suffices your like your understanding why this method works. So time for the pseudo code of the question. So we will have the array n, and we will have the number n, and like let that be whatever it be, and we will have array b in which we have to convert n. So along with that, I will declare a boolean variable. Let's call it yes, and I will initialize it to true. So when you initialize this, okay, so all you have to do is run the loop for I equal to 0, I less than n, I plus plus, and in this loop you just have to check if uh, I plus 1, that is if I equals to 1, then the first element, if I equals to 1, then the first element is divisible by b's ith element. You have to check this, but if it is not equal to in order to make the conversion from a to b possible, we have to check whether b like the element like a's ith element is divisible by b's ith element. But if it is not divisible, what we have to do is just we will make yes as false. We will make a yes as false and we'll break out of this loop, and in the end I will just write a if statement to print. So if yes, then if yes, which means when I write if yes will remain true only if in this loop this if condition was never satisfied. That is when we never found an element such that I plus 1, that is a's ith element, uh, when divided by b, when we never got a remainder other than 0, that we so like if yes remains true, this implies we never got we never got such a condition as true, that is I a's ith element divided by b's ith element equal never like it was always 0, which means that a can be converted into b, and in such condition I will print yes, or else we'll print no. So that's it. Hope you guys understand the questions.